Uh, Hi everybody. Thanks for being here to listen to these talks, and special thanks for the organization committee for the opportunity of being here to talk about the RAMan Search for Extragalactic Symbiotic Systems of Stars, some new discoveries in this spheroidal dwarf galaxy of the local group. And so I'll present the group, the whole team of the RAMSES II working in this project. And it's important to say that the ideas I'll show here started in a pilot project that it was done with a smaller group of people using the force-weighted VLT. And from that, we learned how to make it more successful using the GMOS at Gemini. So all these people were involved with its international collaboration to do this search. Of course, it's not necessary here to introduce again the symbiotic stars, but well, they're so beautiful that I can about to talk about them. But the important thing is remember that this kind of objects are important for the planetary nebula community because, well, in this case, we know that these are wide binary systems in which you have a cold giant, involved star that it's whose part of the wind is being transferred to a hot white dwarf. And well, they are important because in this case, knowing that they are binaries, that they could have disks and also being able to, in certain cases, like in this here, or required to resolve the binary system at the center. So they result in a number of phenomena that you are interested in our community, like shaping, loss of jets, disks, and other phenomena. The thing is that how do you do to count these kind of objects? I'm trying to show you here that, in fact, I don't know how to do it very well, because I'm showing here number of dwarf galaxies in the local group. And the idea is that the number of symbiotic systems in this galaxy. So what you're seeing here, you have dwarf regulars and spheroidals, their distance, mass, and size, this expected number that it's somehow estimated that I'm not going into detail here, and then the number of systems you know. So it's clear here that you need to do a great effort to be able to find all of those that are expected. This is in the case of this dwarf galaxy in the local group. But if you go to the Milky Way, the situation is not better than for these dwarfs, because this is the number of estimated almost up to 400,000 systems. And so far, using the most updated catalog of these systems, at most 300 systems are known in the galaxy, and six, seven in fact, in the external galaxies. So even counting all the other works that come after this one, you don't have 300 of these objects. So you have a long way to go. The way that these guys are found, it's by using in the optical and infrared color diagrams in which you have emission lines like H alpha, and then broadband photometry. And then we find the locus of these objects in, for instance, these two diagrams, the IFAS one and the two mass ones. But then we see here and here as well that we have another two mass color diagram, that there are a number of other stars that occupies the same place as these systems. So the spectroscopy follow-up, it's very important. It's, of course, it's a very costly thing. Then we, in the RAMSES II, our approach is to perform a census of these objects in the dwarf galaxy of the local group, and objects or galaxies with different mass or luminosities, using a novelty approach or technique that it's a one that it's purely based on photometry. And well, I will start for this. So what we're trying to do here is that thing that you use it to do in planetary nebula as well, like using H alpha or O3 emission line that are very strong ones to identify the object. And in this case, you'd use this RAMan 06 line that we see this line in the optical, and because it's this 06 line is RAMan 06 is a scatter of these UV lines, and this scatter occurs because of the presence of a significant column density of neutron hydrogen. So it's very important. I mean, it's very important that you have a source of the UV photons and also a source of this high column density of neutral hydrogen. And this is exactly the kind of systems you have in symbiotic gas. So this emission line is almost unique of symbiotic systems. The way you do this is that use the on-off band technique. So the continue and the on band, and the continue, the adjacent continue. And you do this in H alpha because whatever ionized object you have H alpha in 3, that is our target, and also in helium-2. And this is because helium-2 is like half of the ionization rotation of those 6. And as the continuum of symbiotic stars in this region of the RAMan 06, it's not always well behaved in the sense that sometimes it's flat, sometimes there is all the absorption bands of the core star. So false positives are not rare events. So we do really need to see the highly ionized gas in the other part of the spectrum. So in order to observe all these 6 bands, the on band and off band, we need the H alpha, O6, and helium-2 filters. In fact, we built all 6 filters to the GMOS Gemini in order to do this work. And the first results I had for this, and this was published about 2 years ago. And this was the test we did on the sky for these filters using GMOS at the Gemini telescope. In this case, it was in the south. So what you did is that you chose some systems that you knew in advance that they had the 06 emission. So this is one of the cases. So we have here the field of view of Gemini, and then this is the RAMan 06 on-band emission, and then the continuous subtracted one. So we see very clear there that you have the emission in 06. Another case in a crowded field on that it's a bit more complicated, but it still clearly identify the object here. And there is a third one here in a crowded field as well, on which in this case we knew that this object emits in 06, in RAMan 06, but you didn't find it. So what you did in the night after that you took the photometry, we took also a optical spectrum, and what you see here, what you see here is that the emission is very faint now, 2 years ago. And this paper shows that from 2017 to 2013 to 2017, the RAMan intensity was going down. So this is why you were not able to detect. And then a very nice surprise in this science verification, it was that we also pointed to a LMC 1, a system that so far were known for not showing this emission, but we find it. Again, we took in the next day, in the following days, the spectrum, and you see here the emission. So nowadays, this guy is emitting this design. So with all of this, you prove it that our technique works. And then what we have, I'm showing in the rest is that the data we have to apply these techniques for a number of other galaxies. And you have this four for which we completed the observation with the 6 filters in 2020. And
2 minutes.
the important thing, the important thing here is that we are, selecting galaxies with, of course, small sizes because of otherwise it take too long to map the whole galaxy. Different mass, luminosities and metallicities as well, because then we can compare our results with the effort that is being done the Andromeda and M33, because you don't know how these structures change or the characteristics of them change with metallicity, for instance. And so the first galaxy analyzed, it was NGC, this dwarf spheroidal, that it's a companion of Andromeda, NGC 205. And we chose this one because we knew previously that this one has at least one symbiotic system emitting in the 06, RAMan 06 emission, and another two possible symbiotic systems. So what you show here, it's exposure times, just to have an idea. And in that case, in 2015, we observed two field of views, and this time you have only one. So kind of half of this structure here. The results are here that we were able to identify 4 new symbiotic systems in this galaxy. Of course, we started by recovering the bright symbiotic system 1 from the previous paper in H alpha, in H alpha, helium 2, and those 6 as well. And in the case of the other, one of the possible symbiotic already known, we were only able to see H alpha. The helium 2 is too faint, and we're not able to, to detect that one. And here we see the H alpha, helium 2, and O6 image of the 4 new systems. This is a 10 versus 10 arc-seconds image. And I hope that this convinces you that our technique is working. Of course, you try to find the other observations for these stars. And unfortunately, the true mass and WISE data for them, if they exist, they are lower limits and this kind of thing. So we cannot really classify only with this data the kind of symbiotic systems we have. And finally, it's important to remember that, even though you don't know that much of the symbiotic population, the galaxy, conclusions are possible. Again, in general, for the dwarf galaxies, all these colors is covered in our galaxy. So it's important to know what we know is populations, and we have such tools decided to contribute to these statistics in range of mass, metallicity, and luminosity. The filters you built for doing this work are there available among the narrowband filters of the Digimosa Gemini. So, all people interested in these kind of things can use these filters. And finally, the RAMSES II increased the population of symbiotic systems in this galaxy from 1 to 5. So it's clear that it's a promising symbiotic system number counting technique for this and other dwarf galaxies. Well, thanks for your attention.
Yeah, we're running a little over. Your voice broke up for a while, but I think we got most of your points. Now we just have time for, Sahai has a question.
Yeah, so Denise, really great work, but I'm worried about contamination with young planetary nebulae, compact young planetary nebulae, which can also show the same lines?
Yeah, in fact, we also worry about this. But we know like 5 objects that, well, people are agreed that the emission they found in the 6825, it's due to the RAMSES. But the doubts about these objects, and even though the contamination is very low.
Oh. Now your voice is breaking up again. Yeah, we lost part of your audio.
I would suggest that because Denise is suffering from some problems with the sound, to take all the questions to the slide.